Hello everyone, welcome to my department of sophomore high school. The objective of presentation is to construct an isosceles right triangle. Let's start by application number 1. Let BC be a given line segment as shown in the figure. Construct an isosceles right triangle of hypotenuse BC. Then write down the steps of construction. Before we begin by the steps of construction, it is necessary to imagine in your mind a case in which a triangle ABC is right isosceles. Let's start. Let ABC be an isosceles right triangle of hypotenuse BC. This given gives us two essential conditions. AB equal to AC is due to a reason that ABC is an isosceles triangle. The measure of the angle BAC equal to 90 degrees is due to a reason that ABC is right. Now based on the first condition, where is the location of a point A so that AB equal to AC? It is very clear that A should belong to the perpendicular bisector D of BC. And now based in this condition, where is the location of a point A if the measure of the angle BAC equal to 90 degrees? It is very clear that A should belong to the circle C of diameter BC. Now combine these two results to get C and D are intersecting at 2 points. Name one of them is A and the other is D. Consequently, we have two triangles of hypotenuse BC. Steps of construction. We'll explain all steps of construction by this video. Observe. Step number 1, construct D, the perpendicular bisector of BC. Step number 2, construct a circle C of diameter BC. In both construction of D and C offshore, we use a compass tool. Now C and D are intersecting at 2 points. Name them A and D. Connect the points A, B, D, and C as shown in the figure. Now draw a conclusion. We have two triangles whose hypotenuse is BC. One of them ABC and the other one is BDC. Let's start by application number 2. Let BC be a given line segment. Construct a direct isosceles right triangle ABC of hypotenuse BC. First of all, is there a similarity between this application and the previous application? In both applications, ABC is an isosceles right triangle. The additional given in this application is that ABC is a direct triangle. What do you mean by a word direct? A word direct means to name a triangle ABC. We move or rotate in a positive orientation, which is offshore, a counterclockwise direction. Pay attention to me. How to name a triangle ACB? Look at the figure. To name a triangle ACB, we move in a negative orientation or negative direction. This is why triangle ACB is an indirect right isosceles triangle. Now let's start. ABC is a direct isosceles right triangle of hypotenuse BC. This given gives us two conditions. Condition number 1, AB equal to AC. Due to a reason ABC is an isosceles. Condition number 2, the measure of ABAC pi over 2 of sure plus 2 cap pi is due to a reason that ABC is direct, right? Now, how to measure the angle ABAC? Look at the figure. Put your hand in the direction of AB. Rotate it towards AC. We move by a right angle in a positive orientation. This is why we write this angle measures pi over 2 plus 2 cap pi. Now, based on this main point, AB equal to AC. In this case, actually A belongs to the perpendicular bisector D of BC. Now, based on this point, the measure of the angle pi over 2 plus 2 cap pi, then A belongs to the semicircle C of diameter BC. In this case, don't say A belongs to the circle C. I will explain it by a video of sure verifying this angle. And now, how to draw a conclusion? Combine these two cases. From one side, A belonging to D. From the other side, A belonging to the semicircle. Consequently, A is a point of intersection of the semicircle C and the line D. Now observe the video to explain the steps of construction of a triangle. Step number 1, construct D, the perpendicular bisector. Step number 2, construct C. And now, D and C are intersecting at 2 points, but I name them by A. Consequently, A has 2 possibilities. A is either located in this position or in that position. Let us study each case alone. If A is located in this position, look at the measure of the angle ABAC. Put your hand in the direction of AB and rotate it in the direction of AC. We move by 90-degree angle in a positive orientation. So this position of A satisfying both these conditions. This is why the position of A is correct, and consequently triangle ABC is true in this case. It is a correct choice. Now look at the position of A. If A is located as shown in the figure in this position, what about the measure of this angle ABAC? Again, put your hand in the direction of AB. Rotate it towards AC. We move by 90 degree, but in a negative orientation. This is why the measure of this angle equal minus pi over 2 plus 2 cap pi. Then in this case, the position of A is false. Consequently, triangle ABC in this case is an indirect triangle. So it is an incorrect choice. Final conclusion, whenever we say a triangle is direct right isosceles of sure of given hypotenuse BC, we just have one triangle. In this application, the correct triangle satisfying this condition is the triangle ABC as shown in the figure. And now we finish my presentation, and thanks for your listening.